Alright, so here we are, 7.2. You'll notice you don't recognize this word, but you should recognize this one, rational. So what we're talking about in 7.2, and we're going to put it all together, one video for all of it, even though there's, I think, 2 investigations. But we're going to talk about irrational numbers, okay? And there's basically 2 different categories, and then we'll kind of sum it all up as we get finished, okay? Irrational numbers. The first thing we want to talk about is what's called a square, okay? Now we're not talking about the shape, but the shape gives us the idea. We find the area of a square by taking the side multiplied by the side. Well, the square of a number is that number multiplied by itself. We use an exponent of 2 to represent this idea. The questions are going to say something like, what is the square of, and then give you the number. So 14 squared would be 14 times 14, and then we would actually find the answer. 22.4 squared would be 22.4 times 22.4, and we would get an answer. Okay, so it's a simple concept talking about, basically it came from the concept of the area of a square, side times side. So if we want to square a number, we're going to take that number multiplied by itself. Now the result, if the answer came from a whole number multiplied by itself, it's called a perfect square. So numbers like 25, 81, 400, 1225 are called perfect squares because it took a whole number to multiply together to give you each one of these. 5 times 5, and so on. Okay, so perfect squares are going to be important when we flip to the next slide. Okay, so the square of a number is a number multiplied by itself. Okay. All right. Now, if we have a square, we must have the opposite of the square. In your book, it uses a word called the inverse operation. It points out that addition and subtraction are inverses. If I add 3, I can do the opposite by taking away 3, subtracting 3. Multiplication and division are opposites. Okay. Well, squares and square roots are opposites of each other. Okay. Square root is represented by that symbol. You may recognize it. The answer of a square root will be the number that multiplies by itself to give you the number inside what's called a radical symbol. So if I have the square root of 36, I'm looking for what number multiplied by itself will give us 6. What number multiplied by itself will give us 1089. Some of these are going to be harder than others. Some you should have memorized. Okay, we'll talk about that in class. But these ones, the 36 and the 1089, are both perfect squares. That's why we have a whole number answer, 6 and 33. But not all of them are perfect. So what do we do if it's not a perfect square? Say the square root of 22. Okay. Well, we cannot find this answer on our own. Okay. We have a problem. We can't do this in our heads. Since Mr. Allen is so allergic to little evil demon boxes, we're not going to use them to do this. What we're going to do is we're going to find the 2 whole numbers that happen around the square root of 22. Okay. So we're not looking for the exact answer because we would need a little evil demon box to do that. So what we're going to do is we're going to try and find out where is it found? Where can we locate the square root of 22 on a number line? So we need to figure out what perfect square is below the square root of 22 and what perfect square is above it, because those are the ones that we know the answers to. So what we do is we find that 16 is smaller than 22. 16 is a perfect square, that's 4 times 4. And 25 is above 22, that's 5 times 5. Notice that we found the perfect squares that happen around 22. So the square root of 22 is between 4 and 5. Let's look at another one. The square root of 57. So what I need to do is I need to find the square root that's below the square root of 57. Sorry, the perfect square that's below and the perfect square that's above. Okay? So we should have 49, that's less than 57. And we should have the square root of 64, which is above. Well, the square root of 49 is 7, and the square root of 64 is 8. So this happens between 7 and 8. So we're using that concept of perfect squares to determine what would this be between. Okay. Later on in math, we're going to try and guess about what the decimal might be. Okay. That just kind of teaches you how to estimate and that sort of thing. But right now, we're not going to necessarily worry about that. Okay. Now, remember that this section is called irrational numbers. We haven't even talked about those yet. Well, remember our chart over here that we went through a few days ago with our rational numbers being things like fractions, okay, so fractions, and repeating or terminating decimals, and then we've got our integers with -2 and -7. We have our whole numbers with the number 0, and then we have our numbers that are natural, 1, 3, and 22, okay? Well, we just talked about irrational numbers, so they're right over here. If a rational number is any number that can be put into a fraction or is a repeating or terminating decimal, then an irrational number is going to be a non-repeating or non-terminating decimal. We've already mentioned one number, that's the number pi, and we just saw a bunch of them. The square root of 22 is an irrational number, the square root of 57. Basically, any non-perfect square root is going to fall into the category of irrational numbers. Okay? So we're adding a new category. Now, this whole thing, the red rectangle and the blue rectangle and everything inside the red rectangle, are all called real numbers. Okay? That's the area of mathematics that all of these fall into. Okay? So what we just covered is squares, taking a number multiplied by itself, square roots, finding out what number multiplied by itself equals what's inside the radical, and the concept of irrational numbers and real numbers. Okay? Hope this made sense. If you need to, rewind, whatever, watch it over again. Make sure you take good notes. See ya.